The Cretaceous period, lasting from approximately 145 million to 66 million years ago, marked the final chapter of the Mesozoic era, often referred to as the Age of Reptiles. This dynamic period was a time of extraordinary evolutionary innovation, with the diversification of dinosaurs, the rise of flowering plants, and the continued development of birds and marine animals. Spanning 79 million years, the Cretaceous is the longest period of the Mesozoic era. Divided into two epochs, the early and late Cretaceous, it followed the Jurassic period and culminated in one of Earth's most dramatic mass extinction events. This extinction marked the end of the dinosaurs and paved the way for the dominance of mammals in the Cenozoic era. The climate during the Cretaceous period was generally warm and stable, with no polar ice caps. High levels of atmospheric carbon dioxide maintained a greenhouse effect, creating temperate conditions across much of the planet. These warm climates supported lush vegetation, including the first flowering plants, angiosperms, which began to replace gymnosperms like cycads and conifers as dominant plant species. Geographically, the continents continued to drift apart, further fragmenting the supercontinents Gondwana and Laurasia. This tectonic activity created new coastlines, shallow seas, and isolated environments, fostering biodiversity and regional specialization of species. The formation of the Atlantic Ocean and the presence of expansive seaways, such as the Western Interior Seaway in North America, dramatically influenced marine and terrestrial ecosystems. The Cretaceous period was a time of immense faunal diversity. New dinosaur species emerged, including iconic creatures like Tyrannosaurus rex, Triceratops, and Velociraptor. Birds evolved further from their theropod ancestors, developing advanced flight capabilities. Meanwhile, marine reptiles like Mosasaurus and Pliosaurus dominated the oceans, coexisting with early sharks and bony fish. Additionally, mammals began to diversify, although they remained small and largely inconspicuous compared to the towering dinosaurs. The rise of flowering plants during this period also transformed ecosystems, supporting the evolution of new herbivorous species and insect pollinators. The Cretaceous period stands as a testament to Earth's evolutionary dynamism, showcasing the peak of dinosaur diversity and the beginnings of profound changes that would shape the planet's future. Dinosaur groups of the Cretaceous period. The Cretaceous period, a time of remarkable diversification, saw the evolution of some of the most iconic dinosaur groups, both carnivorous and herbivorous. From massive predators to towering plant eaters, these dinosaurs exemplified the adaptability and specialization that characterized the Mesozoic era. Tyrannosaurus rex, T-Rex, the apex predator. Tyrannosaurus rex, one of the most famous dinosaurs, was a formidable carnivore and apex predator of the late Cretaceous. Measuring up to 12 meters in length and weighing as much as 9 tons, T-Rex was built for power. Its massive skull housed sharp, banana-sized teeth designed for crushing bone, while its strong legs enabled short bursts of speed to chase prey. T-Rex likely preyed on large herbivores such as Triceratops, but fossil evidence suggests it was also an opportunistic scavenger, feeding on carrion. Spinosaurus, the semi-aquatic giant. Spinosaurus, the largest known carnivorous dinosaur, could reach lengths of about 15 meters and weigh up to 7 tons. Unlike most theropods, Spinosaurus was semi-aquatic, adapted to life in rivers and swamps. Its elongated snout, filled with conical teeth, was ideal for catching fish, its primary diet. Fossil evidence suggests Spinosaurus had a large sail-like structure on its back, possibly for thermoregulation or display, and paddle-like limbs for swimming. Carcharodontosaurus was another massive predator, rivaling T-Rex in size. Its name, meaning shark-toothed lizard, reflects its serrated teeth, which were perfect for slicing through flesh. It hunted large sauropods and other herbivores. Baryonyx was a smaller theropod, reaching about 9 meters in length. Known for its long, crocodile-like snout and powerful claws, Baryonyx was a skilled fish hunter, likely wading through shallow waters to catch its prey. Sauropoda, the giant plant eaters. The Cretaceous period saw the continuation of sauropods as some of the largest animals to walk the earth. Brachiosaurus, with its long neck and front legs longer than its hind legs, reached heights of up to 20 meters. It fed on tall vegetation such as conifers, which other herbivores could not reach. Argentinosaurus, the largest dinosaur ever discovered, measured up to 40 meters in length and weighed around 100 tons. It roamed the open plains of what is now South America, consuming vast quantities of plants to sustain its massive size. Ceratopsia, horned dinosaurs. Ceratopsians, like Triceratops, were characterized by their frills and horns. Triceratops, with its iconic three-horned face, used its horns and bony frill for defense against predators like T-Rex. Measuring about 9 meters in length, it grazed on low-lying vegetation such as ferns and cycads. Hadrosaurids, the duck-billed dinosaurs. Known as the cows of the Cretaceous, hadrosaurids were highly social and lived in large herds. Edmontosaurus, a typical hadrosaurid, measured about 13 meters in length. Its flat, duck-billed snout was adapted for grazing on vegetation, including flowering plants that emerged during the Cretaceous. Fossil evidence of skin impressions shows it had a rough, scaled exterior, and its herd behavior likely provided protection against predators. The diversity of dinosaur species during the Cretaceous reflects the dynamic and competitive nature of this period. Carnivorous dinosaurs evolved specialized hunting strategies to dominate the food chain, while herbivores developed unique adaptations to exploit diverse plant life. These evolutionary innovations ensured the survival of these remarkable creatures until the catastrophic end of the Cretaceous. Key features of Cretaceous dinosaurs. The Cretaceous period, lasting from 145 to 66 million years ago, was a time of remarkable innovation in dinosaur morphology, size, and behavior. Dinosaurs continued to diversify and adapt to changing environments, displaying new physical and social traits that ensured their dominance over terrestrial ecosystems. Size and morphological development. One of the most striking features of Cretaceous dinosaurs was the immense variation in size, ranging from the tiny Compsognathus, which measured just 1 meter in length, to the colossal Argentinosaurus, which reached lengths of up to 40 meters and weighed around 100 tons. This diversity reflected the broad ecological niches dinosaurs occupied during this period. Giant sauropods like Argentinosaurus and Dreadnoughtus developed lightweight, air-filled bones that allowed them to grow to enormous sizes while maintaining mobility. Their elongated necks enabled them to browse on vegetation high above the ground, minimizing competition with smaller herbivores. At the other end of the spectrum, small theropods like Compsognathus and feathered dinosaurs such as Microraptor adapted for speed and agility, exploiting niches that required stealth and quick movement. Morphological innovations extended beyond size. Dinosaurs like Triceratops evolved bony frills and horns for defense, display, or thermoregulation. Others, such as hadrosaurids, developed specialized jaws and dental batteries for grinding tough vegetation, making them highly efficient herbivores. Communication and behavior. The Cretaceous period also saw significant advances in dinosaur social behavior and communication. Evidence from fossilized trackways and nesting sites suggests that many species, particularly herbivores like Edmontosaurus and Maiasaura, lived in herds. Herding behavior provided protection against predators, facilitated migration, and helped ensure the survival of offspring. Territorial behaviors and social interactions were likely common, especially among theropods. Fossil evidence of healed wounds and bite marks on Tyrannosaurus rex skulls suggests interspecies combat, possibly for dominance or mating rights. Displays such as frills on Triceratops or crests on Parasaurolophus may have been used to communicate within species or intimidate rivals. Acoustic communication is another area of interest. Dinosaurs like Parasaurolophus had hollow cranial crests that may have functioned as resonating chambers, allowing them to produce low-frequency calls to communicate over long distances. Such adaptations indicate a level of social complexity that mirrors behaviors seen in modern birds and mammals. The Cretaceous period was a time of evolutionary refinement for dinosaurs. From their incredible size range to their complex social behaviors, these creatures exemplified adaptability and resilience, cementing their status as the dominant terrestrial animals of the Mesozoic era. Significant events of the Cretaceous period. The Cretaceous period was not only a time of dinosaur dominance but also a period of profound evolutionary and ecological changes. From the proliferation of flowering plants to the diversification of marine ecosystems and the emergence of birds, the Cretaceous was pivotal in shaping life on Earth. Plant evolution, the rise of flowering plants. The evolution of angiosperms, flowering plants, during the Cretaceous period revolutionized ecosystems. Flowering plants offered new food sources for herbivorous dinosaurs, creating diverse habitats that supported a wider variety of species. Angiosperms were faster growing and more adaptable than gymnosperms like cycads and conifers, allowing them to colonize different environments rapidly. Herbivorous dinosaurs like hadrosaurids, duck-billed dinosaurs, benefited greatly from this plant evolution. Their advanced dental batteries, capable of grinding tough vegetation, were perfectly suited to consume the fibrous leaves of flowering plants. This dietary expansion supported large herds of herbivores, which in turn sustained an ecosystem of carnivorous predators like Tyrannosaurus rex and Velociraptor. Marine ecosystem, the proliferation of marine reptiles. The oceans of the Cretaceous were teeming with life, with marine reptiles like plesiosaurs, mosasaurs and large predatory fish dominating aquatic ecosystems. Plesiosaurs, with their long necks and paddle-like flippers, were adept hunters, preying on fish and small marine animals in coastal waters. Mosasaurs, reaching lengths of up to 15 meters, were powerful apex predators that roamed the open seas. Their flexible jaws and sharp teeth allowed them to consume a wide range of prey, from fish to other marine reptiles. Large predatory fish, like Xiphactinus, grew up to 6 meters long and were formidable hunters in their own right, rivaling smaller marine reptiles in the food chain. These creatures thrived in the warm, shallow seas that covered much of the planet during the Cretaceous, creating rich and dynamic marine ecosystems. Emergence of birds, a major evolutionary milestone. The Cretaceous period marked a critical stage in the evolution of birds, which descended from small theropod dinosaurs. Early avians like Archaeopteryx had already appeared during the Jurassic, but the Cretaceous saw the development of more advanced species with better flight capabilities. Birds like Ichthyornis and Hesperornis emerged, showcasing adaptations such as shorter tails, keeled breastbones for muscle attachment, and feathers optimized for flight. These traits allowed them to diversify into various ecological niches, from forest canopies to coastal environments. The evolution of birds was significant not only for their success in the Cretaceous but also for their survival beyond the mass extinction event that marked the end of the period. As the only surviving dinosaur lineage, modern birds owe their existence to these early avian pioneers. The significant events of the Cretaceous period reflect the dynamic and interconnected nature of life during this era. The rise of flowering plants transformed terrestrial ecosystems, marine reptiles reigned in the oceans, and the emergence of birds marked a pivotal evolutionary shift. Together, these changes defined the Cretaceous as a period of innovation and transition in Earth's history. The extinction of dinosaurs. The end of the Cretaceous period, approximately 66 million years ago, marked one of the most significant extinction events in Earth's history. This event, known as the Cretaceous Paleogene (KPG) extinction, wiped out nearly 75% of all species, including most dinosaurs. The causes of this catastrophic event have been widely studied, with a combination of asteroid impact and climate change being the primary drivers. Causes of extinction. Asteroid impact, the cataclysmic event. The leading hypothesis for the extinction of dinosaurs is the impact of a massive asteroid or comet. The Chicxulub crater on the Yucatan Peninsula in Mexico provides compelling evidence of this event. Measuring approximately 180 kilometers wide, this crater was formed by an asteroid estimated to be 10 kilometers in diameter. The impact released energy equivalent to billions of nuclear bombs, triggering a series of environmental catastrophes. Global fires. The intense heat from the impact ignited wildfires across the planet. Dust and debris. The explosion ejected vast amounts of dust and soot into the atmosphere, blocking sunlight and causing a nuclear winter effect. Temperature drop. The lack of sunlight led to a dramatic drop in global temperatures, disrupting ecosystems dependent on photosynthesis. This combination of immediate destruction and long-term climatic effects devastated ecosystems, leading to the extinction of dinosaurs and many other species. Climate change, volcanic activity and environmental stress. In addition to the asteroid impact, volcanic activity, particularly in the Deccan Traps of India, contributed to the extinction event. These eruptions released massive amounts of carbon dioxide and sulfur dioxide into the atmosphere, causing global warming. An initial period of greenhouse gas buildup led to rising temperatures. Acid rain. Sulfur dioxide combined with atmospheric moisture, creating acid rain that damaged vegetation and disrupted food chains. Ocean anoxia. Increased CO2 levels contributed to reduced oxygen levels in oceans, causing widespread marine life die-offs. These long-term environmental stresses, coupled with the asteroid impact, created a cascade of ecological failures that proved catastrophic for life on Earth. Impact of extinction. The extinction of dinosaurs marked the end of the Mesozoic era and opened the door for the rise of mammals and birds. With dinosaurs gone, mammals, previously small and nocturnal, began to diversify and occupy ecological niches left vacant by the extinction. This evolutionary opportunity paved the way for the dominance of mammals in the Cenozoic era. Birds, the only surviving lineage of theropod dinosaurs, also began to flourish. Their ability to adapt to diverse environments ensured their survival and eventual success in the post-dinosaur world. The KPG extinction reshaped Earth's ecosystems, leading to a new era of evolutionary innovation. While the loss of dinosaurs marked the end of an extraordinary chapter in Earth's history, it also set the stage for the emergence of new forms of life, including the ancestors of modern humans. Legacy and impact of Cretaceous dinosaurs. Legacy and impact of Cretaceous dinosaurs. The dinosaurs of the Cretaceous period left an enduring legacy that continues to captivate scientists and the public alike. Although these creatures have been extinct for 66 million years, their fossils and the knowledge derived from them offer profound insights into Earth's history, evolutionary biology, and the planet's changing environments. The Cretaceous dinosaurs remain an essential focus for scientific research, shaping our understanding of the past and its relevance to the present. Fossils and scientific research. The discovery and study of dinosaur fossils have provided a wealth of information about these prehistoric giants. Fossils, ranging from skeletal remains to trace fossils like footprints and coprolites, fossilized dung, reveal details about the dinosaurs' anatomy, diets, and behaviors. For example, the discovery of Tyrannosaurus rex fossils showcases its role as an apex predator, with its massive jaw structure and sharp teeth providing insights into its hunting strategies. Triceratops fossils with bite marks suggest predatory interactions with Tyrannosaurus rex, offering a glimpse into predator-prey dynamics of the time. Fossilized nesting sites of dinosaurs like Maiasaura indicate that some species exhibited parental care, a behavior once thought exclusive to modern birds and mammals. Fossilized remains of plants and other organisms found alongside dinosaurs help scientists reconstruct entire ecosystems, providing a snapshot of life during the Cretaceous period. For example, the presence of flowering plants in fossilized environments highlights the emergence of angiosperms, which significantly influenced herbivorous dinosaurs' diets and habitats. Influence on modern science. Dinosaurs have profoundly influenced modern science, particularly in the fields of evolutionary biology and paleontology. Studies of their anatomy and behaviors have helped scientists understand evolutionary processes, such as adaptation and extinction. For instance, the link between theropod dinosaurs and modern birds, supported by discoveries like Archaeopteryx and feathered theropod fossils, provides evidence of the evolutionary transition from reptiles to avians. The study of mass extinctions, such as the asteroid impact at the end of the Cretaceous, offers lessons about biodiversity loss and the potential effects of climate change today. Fossil discoveries also guide modern geology, as paleontologists study the sedimentary layers where fossils are found to learn about ancient climates, tectonic shifts, and environmental changes. The understanding of ancient carbon cycles during the Cretaceous helps scientists predict future climate trends. A lasting legacy. The legacy of Cretaceous dinosaurs extends beyond science, influencing culture, art, and public imagination. From educational institutions to popular media, these prehistoric giants continue to inspire curiosity and fascination. By studying their fossils and evolutionary history, we gain valuable insights into Earth's past, informing our understanding of life's resilience and the challenges of environmental change. The Cretaceous dinosaurs, though long extinct, remain a cornerstone of scientific discovery and an enduring symbol of Earth's dynamic history.